Hi, my name is Rafael Almeida, and I'm a geologist at San Diego State University, and I'm a part of the JDP program. I study the geologic record of active deformation. I use a combination of geologic observations, both in the field and remotely, and combine them with geophysical tools to understand better the Earth's deformation. I'm gonna show a few slides here. One of the tools I use is um, active source seismic data. So this is an example from Nepal where we were acquiring seismic data across the main frontal thrust, the active thrust fault there. Another tool we use is seismicity, right? So here we are installing a temporary seismic network in Bangladesh to understand the microseismicity there at the tip of that at that megathrust zone that underlies the eastern half of Bangladesh. And geodesy is another tool that I commonly use. I am interested in convergent margins from subduction to collision, and I'm going to just kind of show some of the projects that I am working on currently. Um, in this project, I'm using active source data from Nepal to constrain the geometry of the youngest fold and thrust belt deformation there. So you can see these active faults, how they're deforming. We can model shortening rates. Um, and I'm also using this same tool, but in this case using refraction to constrain the shallowest deformation. So these are refraction models that just have a few tens of meters in depth to constrain the near surface deformation. We also use geodesy, right, with collaborators to constrain the convergent rates across the Himalaya. So here, these are models of convergence across the Himalayan margin and comparisons to the structure, the geometry of the structures there to see if there's any correlation, as well as trying to understand the relationship between coseismic slip and the geologic structure. So this is an example from the 2016 Gorka earthquake, um, trying to understand that kind of peculiar slip distribution from that earthquake there. So these are collision zones. This is, sorry, another example of a collision zone earthquake in Iran, where again we're using geodetic, in this case SINSAR observations, to try to constrain the shape of the fault of the underlying thrust structure there in the Zagros collision zone. Um, in subduction zones, I am interested in how observations such as seismic coupling help us understand the frictional properties of a subduction margin. I am also interested in studying the structure of accretionary wedges as they represent a geologic record of subduction. So by understanding what happened here, we can kind of we have a record of the evolution of these margins. So this is an example from the Nankai Trough, using kind of cutting edge processing methods to be able to get more information out of existing data. Finally, I have been working lately more on the Ecuadorian subduction margin. So this is a complex area that's characterized by subduction of the Carnegie Ridge right here. This is an aseismic ridge related to the Galapagos hotspot. Then this leads to a subaerial forearc. So this is not a common setting, but this allows us to see a lot of the deformation that would usually be underwater and not quite as accessible. This also leads to arc parallel strike slip. So we can see this fault here. This is slip partitioning due to oblique convergence. And this western side of Ecuador is translating to the north. This is called the North Andean sliver. It's been constrained by previous studies. And then finally, we have active shortening in the back arc. Um, so I am currently working on quantifying the shortening. This is a very poorly understood process. So through a combination of geomorphic observations and geodesy, we hope to constrain the rates of shortening of these structures in the back arc here. So this is the main Andes. We can see these kind of lower lying hills here. all represent this kind of back arc fold and thrust belt. And then finally, we're using the history, the geologic history of the forearc, taking advantage of a series of seismic data that has been acquired for petroleum exploration to understand how the subduction margin has changed, and in particular, how has it changed since the impingement of the Carnegie Ridge. So this list is not comprehensive. I am always open to new ideas. So if you're interested in something else that combines geology and geophysics, don't hesitate to reach out. And thank you for your interest in our program.